This is section 13.5, intersection of events and probability trees. All right, so our first one is, what is the probability we draw two face cards with replacement? With replacement means once we draw the card out, we're going to put it back in. Okay. So probability of a face card and a face card. In a deck, there's 12 face cards out of 52. But once you draw that face card, you're going to take it, you're going to put it back in the deck, replacing it. So the probability to draw a face card on the second draw is 12 out of 52. So that's 9 over 169. And then what is the probability we draw two face cards without replacement? So basically, once you pull a face card, you don't put it back in the deck. So for the first draw, we have 12 face cards out of 52. But once we pull one face card out, how many face cards do we have left? 11. And then what does that do to the whole entire deck when we pull out one card? Changes that number to 51. So that's 11 over 221. What's the probability of drawing a king and a 4 with replacement? King and a 4. All right, so the probability you draw a king, there are 4 kings out of 52 cards. Then we're going to put the king back in. There are 4 4s out of 52 cards. All right, so that's 1 over 169. But there are two ways you can do this. You can do a king and a 4, but that you can also have a 4 and a king. You could add 169 together, or what you would do is you would just multiply this by 2, and it gives you 2 over 169. Now we're going to do the same scenario, but this time it's going to be without replacement. All right, so a king is 4 out of 52. There are 4 4s out of 51. And this you are also going to multiply by 2 as well. So it's 8 over 663. We roll a pair of dice 3 times. Find the probability that a total of 9 is rolled each time. So let's look at the sample space for 2 dice. Again, the total that you have is 36. 1, 2, 3, 4, and there are 5 9s. The probability you roll a total of 9 is 5 out of 36. And what's the probability you roll it a 9 each time? Okay. For this, so 0.0027. Assume a softball player has a 0.88 probability of getting a hit at each bat. The probability she gets a hit is 0.88. So the probability that she misses is 1 minus 0.8, so 0.12. 88% of the time she gets a hit, 12% of the time she does not. Assume that the player bats 4 times. What is the probability she gets a hit only at her first bat? Okay, and she's batting 4 times. So we have a hit times a miss times a miss times a miss. Let's do 4 decimal places. 0.0015. Remember, you want to check to see how many decimal places they want. They may just want 3. So just read the question and see. Imagine a subject is taking part of a study to test a new cold medicine. The probability that the drug the subject is taking, drug A, is 10%. Probability of taking drug B is 40%. And the probability of taking drug C is 50%. From past clinical trials, the probabilities that these drugs will improve their condition, A, the ones that took drug A showed 10% improvement, so the ones that didn't show improvement, had no change, was 90%. Drug B improvement was 60%, so 40% of those patients had no change or no improvement. And drug C, they showed a 30% improvement, so that means there's 70% no improvement. This one's just going to be multiple choice. You just have to pick the correct diagram. A person wants to purchase a DVD for his laptop. Assume that 88% of the drives are made outside the U.S. Of the U.S. made drives, 4% are defective. Of the foreign made drives, 7% are defective. Determine probability that it is made in the U.S. and not defective. All right, outside the U.S. is 88%, so the ones that are made inside the U.S. is 12%, so it's 1 minus the 0.88. Of those made in the U.S., 4% are defective, so that means 96% or 0.96 are not defective. We don't even use the 7%. So 0.1152. Assume that you're drawing 2 balls without replacement. So once you pull a ball out, you're not going to put it back in, from an urn that contains 17 green, 14 blue, and 9 red. Let's add those. So the total they have is 40. What is the probability that you draw a green and a blue? All right. So the probability you draw a green, we have 17 out of 40. And then once you pull out the green, the total becomes 39. The second draw, you draw a blue one, so that's going to be 14 out of 39. And this is similar to one we did before. You could pull the blue first, and then the green. So once we get this answer, we are going to multiply it by 2. $19. gives me, what's 19 over 390. And that is it for section 13.5.